Hello, everyone, and welcome to another session of Learning Mathematics Conceptually with Mrs. Bentley. For today's topic, we are going to be looking at Introduction to Algebra and Algebraic Vocabulary. Class participation is key. So at intervals within the lesson, activities will be given to check your understanding of mathematical terms and concepts and to assess the quality of the lesson. You'll be given 10 seconds to complete each task. However, you can always pause the video if you need more time. However, ensure that you attempt all tasks. Always remember, I can't know what you know unless you show me, and in showing me what you know, you will realize what you truly know. By the end of this lesson, you should be able to differentiate the terms associated with algebra, differentiate between variables, coefficient, constant, and the terms, identify like and unlike terms in a given equation or problem situation, and appreciate the use of algebra in everyday life. So let's get into it. What is algebra? When we hear the term algebra, what are we talking about? So algebra is the branch of mathematics that deals with unknown quantities. So quantities that we need to find some unknown, that is algebra. Or unknowns are represented using symbols and letters. For example, 10 plus 9 equals x. Here we have some known quantities or values, 10 and 9. But we want to know what our result is going to be when we add them together. We do not know what the result is, so we use an x to represent our unknown value. In this situation, x is being used as a placeholder. In an essence, what we need to find is the value of the unknown. So this represents algebra. This is an algebraic equation. But what is an algebraic equation? An algebraic equation is when you have an expression being equated to another expression. When we get further into the lesson, we're going to find out what expressions are. But for now, once we have two expressions with an equal sign, or to say that one expression is the same as another, this is what is known as an equation. For it to be an equation, there must be an equal sign. Now that we have covered what an equation is, let's see how to solve this problem. So what is the value of the unknown? 10 plus 9 equals x. If we add 10 plus 9, we end up with 19. So this is saying that 19 is equal to x. Therefore, x is equal to 19. As we get more into it, the problems become a little bit more difficult, but the basic is always going to be that we're trying to find the value of some unknown. So we're going to be looking at algebraic representations. Writing algebraic sentences. If we look at this tree, we want to find what letter or symbol can you use to represent the apples on the trees. So how many apples are on this tree? And how would you represent the amount of apple on the tree? Yes, there are 3 apples on the tree, but how would you represent this using algebra? Alright, so let's see. Again, we can use symbols and letters to represent our unknown or to represent our scenarios. So we can use just about any letter or symbol. It's up to us what we choose. So if we say let apple equals A, then it would be 3A. If we say let apple equals C, then 3C. But if apple is equals to X, then it would be 3X. Always remember, you are the one who is going to define your scenario. Once it's not a given, then you are able to use any letter or symbol you choose. But first, you must define it by saying let equals, and then we put our symbol or our letter. So there are 3 apples on the tree. We decided that we can choose to use any letter or symbol to represent our apple. But can the same symbol be used for different items or scenarios? What do you think? Yes, we can use different letters or symbols to represent a specific scenario. But what if we have different scenarios? Can the same symbol be used to represent them? Let's see. Think about it. All right. So for example, we start out with our apple tree. On this apple tree, we have 3 apples. So let x equal apples or apple equal x. Then 3 apple would be the same thing as 3x. But here we have some fingers. We have 5 fingers. If let fingers equal x, then 5 fingers equal x. So we're talking about 2 different things, but we're using the same letter or the same symbol. Is this okay? Yes. The same symbol can be used to represent different scenarios. But can the same symbol be used to represent different values in different equations? Let's see. So 10 plus 9 equals x. Then 19 equals x, which can be read as x equals 19. Let's look at another question. X plus 3 equals 8. So again, we'd like to find the value of x. So we're going to ask ourselves, what can I add 3 to give me 8? 5. 5 plus 3 equals 8. Therefore, x is equal to 5. It therefore means that the same symbol or letter can be used to represent different values in different equations. But what about using the same symbol or letter to represent different values in an algebraic sentence? Is this possible? Let's see. 8 plus a equals 6. So we said that we want to see if the same a can be used to represent different values. So we're going to ask ourselves, what are the whole numbers that can be added to give us 6? We can have when a equals 1 and a equals 5, 1 plus 5 equals 6, or the first a equals 5, the second a equals 1, 5 plus 1 equals 6. We can have 2 plus 4 equals 6, or 4 plus 2 equals 6. We can even have 3 plus 3 equals 6. The same symbol cannot have different values in the same equation. Why? Because a cannot be 1 and 5 at the same time. How would we know which value of a to write down? It cannot be the same for this specific equation. So no, it would not be true. The only way for this equation to be correct is if a equals 3. So within a given equation, the same symbol or letter cannot have two values. What about if two unknown have the same value? So in this case, we will have two different letters having the same value. Is that possible? Think about it. Could that be possible? Let's see. So let's start out with a plus b equals 6. Again, if we're supposed to think of all the numbers that can be added together to give us 6, we can have it such that a equals 5 and b equals 1, where 5 plus 1 equals 6. Similarly, we can have it such that a equals 1 and b equals 5, which would give us 6. A could also be 2 while b is 4, or a is 4 while b is 2. Our value will still be 6. What about a being 3 and b equals 3? Indeed, 3 plus 3 would give us 6. It therefore means that a and b can have the same value in the same equation, and a and b can also have different values within the same equation. It goes without saying that the value of a varies depending on the values of b. And this is the reason why our letters or our symbols are considered to be called variables, because the value of the symbol or letter varies based on the question or scenario that is given. So what are variables? Variables are any letter or symbol used to represent an unknown. For example, X, Y, B, C, R, Q, etc. Or variables are usually written with common letters. Let's do this quick activity. So we're going to look at the diagram below, and we're going to try to create an algebraic equation in terms of X and Y. All right, so you have 10 seconds to attempt the question. All right, so what did you come up with? Let's see. If we say let the circles equals X, we will see that we have two circles, that would be 2x. We have two rectangles, so let's rectangle equal y. So we'd have 2x plus 2y, and since a balanced scale, so that means it's equal to 8x. The solution is 2x plus 2y equals 8x. Now let's continue. Constants. This is another algebraic vocabulary. What are constants? Our constants are our numbers. Simple as that. So the numbers within our equation, these are what we call our constants. They will always have the same value. For example, a 5 will always be equals to 5. It will always be the same as 5. It is not going to vary based on the different questions. In every question that you get, 5 will always be equal to 5. Our next term is coefficient. What is the coefficient? So here we looked at 3x being 3 apples. It simply means 3 times x. So our coefficient multiplies the variable. 5y would be 5 times y. Negative 3g would be the same thing as negative 3 times g. Similarly, if we have y, it is the same thing as 1 times y, because we're simply saying, what do I multiply y by to give me 1? And we know that 1 times any number is going to give you back that number. So it's the same thing. So 1 times any variable will give back that variable. If we have negative g, then we know it's negative 1 times g. So that's what our constant is. Our constant simply multiplies the variable. So we have a quick activity for us to try today. So we're going to try to identify our constants, or coefficients, and our variables. We're going to use a green marker to circle the variable, a black marker to circle the coefficient, and a red marker to circle the constants. So again, you have 10 seconds. If you need more than 10 seconds, you can always go ahead and pause the video, and all the best. All right, so let's see what you did. So we're going to start with the first question. Negative 23 plus 2q. What would be our variable? Remember, our variable is our letter. So our variable is q. What is the coefficient? Again, the coefficient multiplies the variable. So they're directly beside each other. So there's no operation between them. In this case, our coefficient is 2. And of course, our constant, which is our number, is negative 23. How about this one? 17q. Let's see. All right, so our variable would have to be our letter, which is r, and our coefficient would be 17. If we look carefully, we realize that for this specific one, there is no constant. So can we really have algebraic terms without constants? Wow. We're going to be exploring that shortly. So let's continue. Again, we're identifying our constants, or coefficients, and our variables. So let's look at negative 8 plus p. What is our variable? Very good. So our variable is p. Again, our variable is our letter. Is there a coefficient? If we recall, p is the same thing as 1 times p. So yes, there is a coefficient. It's just that our coefficient is not represented in this situation, or this scenario. So the p, which is the same thing as 1 times p, can be written as 1p, but the simpler version, or writing it in its simplest term, would simply just be p. Hence the reason why we are not seeing the coefficient. So there would be nothing for us to circle. But if your teacher is supposed to ask you, what is the coefficient? Then you'll be able to say p is being multiplied by 1. Therefore, the coefficient would be 1. And negative 8 would be our constant. So let's move on to the final question. For this problem, we have two variables beside each other. We have s and t. It simply means s times t. So this is saying 4 times s times t. So it's okay to have two variables. beside each other. It simply means that they're multiplying themselves, are multiplying each other. Or other variable would be L. 4 is a coefficient. 4 is the coefficient of ST, and 31 is the coefficient of 31L. So 31 would be the coefficient of L. 31 multiplies L. So that is it. It's okay to have multiple variables and multiple coefficients for the same problem. It's also okay for there not to be any constant. Earlier, I would have alluded to the word term, and you might have been wondering, but what are terms? It's any variable, any constant, or any product of coefficients and variable. For example, y and t, these would be our variables. So these are terms. Any constant, example, 3 and 5, these are terms. Any product of a coefficient and variable, for example, 5x or 6z squared. If we recall 31L minus 4ST, we have two terms, and each of these terms are a product of a coefficient and a variable. But if we look at 13t minus 3y minus 12, here we have variables, we have product of coefficients and variables, and we have a constant. If we're supposed to count each of these terms, we would end up with 3 terms. So different scenarios or different problems would have different amounts of terms. It's important to note that our terms are often separated by our operators or operations. Let's do another quick activity to see if we truly understand how to count the terms in a problem or scenario. Again, you'll be given 10 seconds for this activity, and if you need additional time, you can pause the video. Okay, so let's get started. All right, so that is time. So what were our solutions? For A, 3r minus 5, we have 2 terms. For B, 3 terms. For C, which is just a constant, it would be 1 term. And for D, it is 4 terms. So if you got all of them correct, great work. Good job, and here is a star or a sticker for you. All right, so we are going to continue with 5x plus 3. Here we know we have 2 terms. We have 5x and we have 3. But if we look carefully, we realize that our terms are separated by a plus sign. This plus sign is what we call an operator or operations. Our operators would be the same as our arithmetic operations or our basic operations: addition, subtraction, multiplication, or division. When we have a term or terms plus an operator, we get what is called an expression. So we have 5x plus 3, it becomes an expression. Algebraic expressions, they are one or a combination of terms. They can be variables, constants, or coefficients and a variable. Or expression is when we have, or expressions are formed when we have terms being separated by an operator. And if we look carefully, we realize that even though we have an expression here, we do not have an equal sign. So expressions, for it to be an expression, there should be no equal sign. Just like for it to be an equation, we must have an expression being equated or being the same as another equation. Want to also look at exponents or indices. For example, x squared. What does it mean? X squared means the same thing as x times x. So if we look at 3 squared, it would mean 3 times 3, which is 9. So x squared is the same thing as x times x. So in indices or exponents, they show that a number or a variable is multiplying itself a specific amount of time or a specific number of time. Here's another activity. For this activity, we're going to determine what is the constant, what is the variable, what is the coefficient, is it an algebraic expression, and how many terms are in each expression or terms. So let's go. So for the first one, our constant is 8, our variable is x, the coefficient is 4 because it is what is multiplying our variable. Yes, it's an expression because we have a plus sign, and if we count, we only have 2 terms. For our second problem, y minus 6. Yes, we have a constant. Our constant will be negative 6. Our variable will have to be y. Our coefficient is 1. Remember, y is the same thing as 1 times y. And yes, it's an algebraic expression, y, because they are added. It is separated by an operator. Y minus 6 equals y plus negative 6. So yes, it is an algebraic expression. How many terms? 2 terms. For 9a, if we look at it carefully, we realize we don't have a constant, and that is okay. It's okay for us not to have a constant. But our variable is a, coefficient 9. No, it's not an algebraic expression because the terms are not added together, and there is only one term. And we could finish using the same process. This is another activity for additional practice. Unfortunately, I will not be showing the results for this one, but you can go ahead and attempt the questions individually. So you're going to identify the terms, the coefficients, and the variables, and you're also going to state the number of terms in each expression. This is another extend activity. You're going to create a concept map to show the relationship between terms, equation, algebraic expression, coefficients, constants, and variables. And I'm really excited to see what are some of the things that you guys can come up with. How would you graphically, or how can you get a diagram to show what all these terms represent in relation to the other. So we are finished exploring the concepts, so the vocabulary. So here is our recap activity so that we can see if we really understood what the different vocabulary means. Again, we're given 10 seconds to complete. All right, so that was more than 10 seconds. What were the answers that you came up with? So if this is what you got, then you were correct. So algebraic equations equates two or more expressions. Expressions are a combination of terms which consists of constants, coefficients, or variables. They are separated by mathematical operations such as minus and plus. So if you got everything correct, very good. It shows that you are indeed understanding the concepts that are being taught, and that is wonderful. Now we're going to be creating some algebraic uh, terms, our algebraic expressions. Unfortunately, the remaining of the instruction is not showing. I'm not sure why, but let's look. It says, write one expression that satisfies at least two of the conditions listed below, and write one expression that satisfies all of the conditions listed below. The conditions are terms where the coefficient is 1, but the 1 is invisible, terms that have fractions as the coefficients, and expressions that do not have a constant. Again, you have 10 seconds. You can always pause the video if you need more time. All right. So of course you would have come up with your own solutions, because that's why I like create activities, because everybody can come up with their own thing and everybody's work would be unique. So this is what I have. These are the examples that I have. I don't expect you to have the same examples that I do. So for where it only satisfies two of the conditions. So it said there where the terms have a coefficient of 1 but it's not visible, 4x plus z. Z would have a coefficient of 1, it's not visible. And terms that have fractions as the coefficient, in this situation, I have 4x plus z minus x quarters. In this case, the coefficient of x would be 1/4. Let's look at one that satisfies all three conditions. So again, my a, it has a coefficient of 1, but it's not showing because 1 times a is a. Yes, there's a fractional component, which is negative b thirds. The coefficient of b would be 1/3. And of course, the expression does not have a constant. So now we're going to look at writing worded scenarios in algebraic terms. What does that mean? How is it done? Randall went to the supermarket to purchase fruits. At the supermarket, he purchased 2 mangoes, 3 apples, 1 banana. How can we define these values or these items in algebra? What symbols or letter can we use to represent the different fruits that were purchased? Okay, so I'm going to let M equal mangoes. I'm going to let P equals apple. Let X equal bananas. With that being said, he would have purchased 2M or 2 mangoes plus 3P, 3 apples, plus X, which is 1 banana. On his way home, he stopped at Miss Brown's fruit stall where he purchased 3 bananas, 2 pineapples, and 4 plums. All right, again, we are going to be required to define our terms or our variables. So I'm going to, again, let M equal mangoes, because we cannot have two different symbols for the same value. So if we're talking about mangoes, the symbol that we use to represent mangoes has to be constant throughout. We're going to let pineapples equal A and plums equals X. Sorry. There seemed to be some typo here. Let's quickly correct. On his way home, Randall stopped at Miss Brown's fruit stall where he purchased additional fruits. He purchased 3 more mangoes, 2 pineapples, 4 bananas. So because we already defined mangoes as M, we cannot change it. So the variable for mangoes, it has to remain the same throughout the problem. We cannot have 2 different symbols representing the same thing. We already looked at that. We're going to let pineapples equal A, and we're going to let bananas equal X, since banana would already be represented with X. Therefore, we would say that he purchased 3M plus 2A plus 4X. We can go ahead and put all of this together, and the total fruit that Randall would have purchased would have been 2M plus 3P plus X plus 3M plus 2A plus 4X. But can this expression be simplified? I mean, we have M, we have 2M terms, we have 2X terms. Can we simplify this expression? Can we make it easier to write? It seems to be a little bit lengthy. Can we make it shorter? If we go ahead and regroup or rearrange the values or the terms so that the terms that have the same variables are beside each other, then we can go ahead and simplify, because 2M plus 3M, which would be 2 mangoes plus 3 mangoes, would be the same thing as 5 mangoes. So we can go ahead and write 5M. The same thing for bananas. 1 banana plus 4 banana would be 5 bananas. Banana is equals to X. So therefore 5 bananas would be the same thing as 5X. We would write 2A and 3P. But could we simplify it further? Can it be further simplified? What do you think? No, it cannot be further simplified. Why? Because all of these variables, they are different. Different variables would make the terms be considered unlike terms. Why? Because they are talking about 2 different things. We cannot add or subtract unlike terms. So there is no way to add bananas plus mangoes to get banana or mango. So because of that purpose, we have to leave it as is. So 5M plus 5X plus 2A plus 3B would already be in a very simple form. So earlier we said unlike terms have different variables. What are unlike terms? What are liked terms? So like terms have the same combination of variables and or numbers as each other, but the coefficient can be different. For example, if we have 5 and 7, these are like terms because we are comparing constants. If we have 3z and 5z, these are like terms. Why? Because our variables are the same. If we have negative 2 QR and 5 QR, these are like terms because the combination of variables are the same. But what are unlike terms? Unlike terms would be the opposite. There are terms which have different variables or the same variables with different exponents or powers. So if we have 8 and a 7y, we have a constant and a combination of constants and coefficients, variable and coefficients. So these are unlike. Same thing here where we have 4y and a 6a, where we have a y and we have a. So these are unlike terms. And if we have x squared and x, recall that x squared means x times x, and x simply means x times 1. So these would be unlike terms. It's important to note that to identify a like term or unlike terms, we look at the variables and the exponents or powers or indices, but we do not look at the coefficients. The coefficient doesn't matter when we are talking about like and unlike terms. We're almost at the end of our session, and I would like us to complete this model to tell what is a definition for like terms. What are the characteristics of like terms? What are some examples of like terms and what are some non-example? As per usual, whenever tasks are given, you are given 10 seconds. So what did you come up with? All right, so this is what I would have come up with. So definition: variables, they have the same, these are terms with the same variables and or numbers as each other. Characteristics: the coefficient can be different, but the variables have to be the same and the exponents have to be the same. What are examples? Just like before. And what are non-examples? Or non-examples would have been or unlike terms. So I'd like you to complete or to do the same thing for unlike terms. So you can do this. There's no solution for this one, but it's the same procedure. So we're practically at the end of our presentation. We just want to look at algebra in real life. Is algebra just used in books? Is it just a topic that they teach or a concept that they teach in school? What is the purpose of algebra? Why learn algebra? All right. So algebra is used for time. So whether we're aware of it or not, so when we are setting time frames to complete different tasks or activities on a daily, we're actually using algebra. So the time that we wake up, the time that we use for eating, for going to work, the time that we plot or we put aside to sleep, we use algebra in everything we do because we are not sure how much time we're going to be using, but we're still making preparation for the time. So for brushing of teeth, for bathing, for eating, we use algebra. We also use algebra for budgeting. So when we get our monthly salary, we're going to need the money to do a lot of stuff. So in us planning the amount of the money that we're going to use for rent or housing or mortgage, in the amount of money that we're going to use for groceries, for savings, the amount of money that we're going to put aside for paying our bills, we are using algebra because we also need to consider if, for example, my utility bill goes up this month, it's going to affect the amount of money that I am going to have overall to use. So the variables come into being, and so we have some constants. For example, our mortgage remains the same every month, or rent remains the same every month, but we know that the utility the amount of electricity that we use every month, it varies. So we are using algebra in everything that we do on a regular day-to-day basis. Where else do we use algebra in real life? So we use it in business. So we use algebra for trading, for stocks, just about all of these things. We also use algebra for sports. So if we are going to throw or toss a ball into a net, we have to consider the force that we're going to be using, the angle that we're going to hold the ball at, and along with other things. Even though we may not be literally grabbing a pen or a paper to do these calculations, we are predicting and we are considering the different odds. And so yes, we are using algebra. So again, sometimes we learn concepts in school and we do not know that we are using it every day because we are not grabbing our books and calculating. That's because at that time in our lives, the topic becomes a part of our lives, or the concept becomes so much a part of our lives that we don't have to calculate it. We can have a mental idea of what it is. Just like we may have simple numbers to add, we do not go and grab a calculator to add these values because we are able to do it mentally. We also use algebra in cooking. We talk about the ingredients. So if I want to scale my recipe, my cake recipe up, then if my original recipe was 4, it would have made 4 slices of cake, or 4 servings of cake, and I have a bigger group to feed. My family is a little bit bigger, so then I would have to increase the amount of ingredients that I am going to use. And I do not go ahead and just increase the flour and leave the sugar at the same level. So if I am going to change one value, then I have to change all the other values. We also use it in health and to consider the steepness of a mountain. So we use algebra every day. When we want to find the gradient of something, we use algebra. We think about our heart rate, we use algebra. Algebra is used for graphing. So algebra is used in a lot of areas of our daily lives. So to quickly recap what we have done today, we have looked at algebra. So algebra is a branch of mathematics that works with unknown. We looked at variables, which represents the different unknowns, and we represent our variables with symbols and letters. We look at constants, which are the numbers. We looked at coefficients, which multiplies our variables. For example, 5a is the same thing as 5 times a. A term is a variable, a constant, or the product of a coefficient and a variable. We looked at expression being a combination of terms and operators, or terms being added and subtracted to each other. We looked at equation being a comparison of expression using an equal sign. Like and unlike terms, we looked at like terms having the same variable and exponent, but the coefficients can be different. Unlike terms have different variables and or exponents. And algebra is used to represent patterns and rates or graphs in real life. So every day we use algebra in everything that we do. And this is the end of today's video. This is the end of this lesson. Please be reminded to take your notes if you need them and to complete all activities that are within the video. I can't know what you know unless you show me, and in showing me what you know, you will realize what you really know. With that being said, have a wonderful rest of your day and see you next class.